All right, we're going to look at volumes here. They're on page 611 of your book. I've listed the homework that's going to be due next week. So there it is. Part of it is the grade staking that we did earlier, and the other part is just stuff on volumes. All right, now we use cross sections to find the volume of cuts and fills on a project. So we take cross sections on the site before we build anything. Then we take cross sections of what we're building. And between those two things, we can figure out how much cut or fill was done in the job by using those cross sections. So to find cut and fill volumes, what you do is you calculate the area for each cross section. Okay, then you use formulas to calculate the volumes between these sections that you've calculated the area of. Then you add up the volumes between the sections to get to find the total volume that you have in your project. So the first thing we got to do here is find areas. Now there's a lot of ways to do that. I've done estimates just using graph paper and counting squares. I've done that before. There's also an instrument that was used kind of before the digital age. It's called a polar planimeter. It has an anchor block. It has a sight that you run around the area, and it has a scale that you read to determine the area. Kind of an interesting little instrument that you could use to find the area of an irregular shape. You know, and there's a set of calculations that you would use to use this thing. There's a certain way you use it. We don't do that so much anymore because we're in a more of a digital world now, but that was an instrument that can be used to find an area off of a paper map. Called a polar planimeter is the name of this thing. Okay. Now in this class we'll find areas just by using basic geometry. So we'll start with simple figures. You know, the area of a rectangle is the length times the width. Area of a triangle is 1/2 base times height. If we have a trapezoid, what we can do here is take the average of the base and the top width there, so b plus w over 2, and multiply that by the height, and that'll get us the area. What we're doing with that formula is we're taking a triangle off of one side, flipping it, and putting it on the other side, and that gets us a rectangle. The average width of that, the average dimension here would be the original b plus the original w over 2. Okay. And then you multiply that by the height, and that gets you the area. That formula is on the left-hand side of your formula sheet. All right, so you could find the area of this trapezoid here. Just take the base plus the width over 2 times the height. So you could give that a run on your calculator there. And I think if you do, you should come up with 175 square feet. All right, now in your computer, and in the old days of surveying, they used to use a standard formula for finding the area of shapes that have coordinates around them. It's called the double meridian distance formula. You set a baseline, and then by using the coordinates, you can break that shape up into a series of triangles and trapezoids. And then you can add and subtract them together, kind of as I'm showing here with the hatching, to come up with an area. And it turns out there's kind of a standard way to do it. It's the formula that I've circled here. Now, we're not going to do that in class. It's a bit much, but that's what's happening inside your computer when you have areas and it's finding areas. Now, we'll also do 3 level sections, which are found on the left-hand side of your formula sheet too. The area to find the area of a 3-level section, you take the top width over 4 plus the sum of the height left and right. And then you take the center height over 2 times the sum of the distance left and right. Okay. Now that formula comes from breaking the shape into triangles and finding the area of each triangle, adding them up, and then simplifying. So what you do there, you take the top width, break it into 2 parts, w over 2 and w over 2, and then you've got the area of these triangles here on either side, w2 times hl over 2. Okay, that's w over 4hl. Do the same thing on the right. It's w over 4hr. Then you could figure out the area of these triangles here. That would be that center height times the distance left and right. So you'd go 1/2 center times distance left and add that to 1/2 center times distance right. So I didn't quite say that properly in my first sentence there, but here's the formula there. So 1/2 center times distance left plus 1/2 center times distance right. Then you have this formula here. You can kind of simplify it a little bit and turn it into the formula on the bottom. That's on your formula sheet on the left-hand side as well. So that's a 3-level section. That works pretty well if you've surveyed 3 points on the ground before this berm. Let's say this is a berm was built. One at what we call the catch point, one in the center, one at the far catch point. Then if we survey the berm after it's built, we could intersect the two, and that would be a fair representation of a berm. Okay. So you could look at this one and find the area of this 3-level section here just by applying the formula. Okay, and you ought to come up with 217.5 square feet. All right, so that's just a quick run through areas there. We'll use them then to come up with volumes, and that'll be on the next recording after this.